Hi class, we need to take a look at the next section. And in this section, we're going back to a topic that it's actually similar to what we've done before, which was the volumes, except that in this scenario, we're looking at the surface area that's actually created by revolving a function along the x or the y-axis. And the main objectives for surface of revolution is basically just rectangular and parametric. So those are the main objectives. On a regular semester, we would have gone over polar as well, which just turns out to be a little bit messier than what you're going to encounter here. So those are the two formulas for rectangular, and then this is the formula that we're going to use for parametric. Also, some of these problems, you may encounter that, well, as you're trying to evaluate that integral, you may need a numerical approximation. So something along the lines of Simpson, trapezoidal, or midpoint rule. So let's take a look at the first problem. And some of these are really short. Others could be really messy. And because of the square root, I'm talking about this square root, may require a specific factorization for them to work nicely and evaluate those integrals. Okay, so let's take a look at this problem. And we're revolving it along the actual x-axis. So the surface area, in this case, I'm just going to define that as S is equal to, and we're looking at a 2 pi, and the formula uses your f of x or your y. And let me just rewrite it as f of x times the square root of 1 plus f prime of x, technically squared. I'm using that portion. And then we're going to evaluate this, whoops, I forgot the integral, from a to b dx. And because of how messy, wait, I wrote this wrong. Okay, my bad. I put it's this. There you go. So from a to b. And let me just double check. So AB, 2 pi f of x, and then the square root. Okay, my apologies. And let me actually evaluate f of x and then simplify it on the side. So for this function, our f of x, let me use blue. Our f of x happens to be 2 square root of x. Then f prime of x is equal to, well, 2 times technically a half, x to the negative 1/2, which is equal to 1 over x to the 1/2. And then obviously we're assuming that x is not equal to 0. Let me box that in. We may need it in a later step. And then let me do f prime of x, technically squared, which is going to be 1 over x to the 1/2. Squared, which is just 1 over x. That would represent f prime of x squared. So a lot of these problems, they tend to be really messy if you're actually evaluating everything inside of the square root, especially because you may have messy fractions. So let me actually evaluate the function. So we still have that the surface area is going to be equal to, and in this case we're looking at 1 to 3, and it'll have a 2 pi times 2 square root of x, and then square root of 1 plus, and the derivative of the function squared ended up being 1 over x dx. And technically we still have this huge square root. And for the next problem, let me actually extract the constants. So extracting the constants, it's going to give us a 4 pi integral from 1 to 3 of the square root of x square root, and let me just put the dx there. Now the best step for any of these problems that have a messy fraction, and this may not work for all of them, is to simply get an LCD. And your LCD is going to be x. So in this case, we're going to be expressing the 1 plus 1 over x as x plus 1 over technically x. And then what I'm going to do next, and this is just to make sure that this is clear, you multiply times x and times x. And then what I'm going to try to do is reduce that square root with this x. Now you can't cancel those yet. Technically, you have to do the following operation. So we still have 4 pi integral from 1 to 3 of the square root of x, and I'm going to separate the roots. So you technically have x plus 1 over the square root of x dx. And then at this point, those cancel. So we're left with this being equivalent to 4 pi integral from 1 to 3 of the square root of x plus 1 dx. And you have to be very careful to ensure that if you do any cancellation, you're only canceling, well, in this case, like terms. So we technically couldn't done the cancellation at this step because of the actual 1 in this position. Also, a minor algebraic error will make this one into a we cannot evaluate type of thing. Okay, so at this point, u substitution will do it. So let u equal to x plus 1, then the u is equal to dx. For x is equal to 1, your u is equal to 1 plus 1, which is 2. X is equal to 3, or u is equal to 1 plus, actually it should be 3 plus 1, same thing, so 3 plus 1, which is 4. Those will be the new limits of integration. So let me rewrite it. We're looking at 4 pi integral from 1 to 3 of the square root of u, and this will be du, and I already forgot to replace the limits, so we're going now from 2 to 4 on our u integral, which is simply going to be 4 pi times u to the 3 halves divided by 3 halves evaluated from 2 to 4, or in this case 4 pi times 2/3 u to the 3 halves. We still have the 2 to 4. So we're looking at 8 pi over 3 times u to the 3 halves. And then we're gonna just evaluate the 2 to 4. Simplify as much as you can. So let me go in this direction because I'm running out of space. So this will be 8 pi over 3 times, well, technically 4 raised to the 3 halves minus 2 raised to the 3 halves. We can't definitely further simplify this because this is just 4 raised to the 1/2 raised to the 3rd, or technically 2 raised to the 3rd, or 8. But if you leave it like that as an exact answer, that's perfectly fine. Let me just rewrite it as 8 pi over 3 times 8 minus 2 to the 3 halves. So I would be very happy with this as a final answer, or the one above it. You really can't simplify much that previous one. So if you left it like that, that would have been fine. In this case, we would just say units and units. And let me evaluate to tell you what I'm getting. So I'm looking at 8 . Okay, so the decimal approximation, and I may ask that the decimal approximation on the final exam, if you see one of these, or on exam 3, we're looking at 43.33, rounding to 2 decimal places, and it'll be units. So that's actually it for this one. As I mentioned before, they could tend to be really messy, just because of the nature of the square root.